Hello everyone, this is K. Sandhya Rani, and in this video I would like to discuss about Laplace transform of derivatives and integrals topic in the subject Laplace transform, numerical methods and complex variables. Okay, so first let us try to understand Laplace transform of derivatives till third derivative. Okay, so till now we have discussed about many kinds like Laplace transformation of standard functions, Laplace transformation of combinations. In that combinations, if we have exponential term, first shifting theorem should be utilized. If not, two functions containing the variables of the same kind like t minus a, then second shifting theorem will be utilized, and Laplace transformation of multiplication by powers of t and division by t. So after this, we have Laplace transformation of derivatives. In that, if we try to understand the formula of these Laplace transformation of derivatives, usually everybody, where the function in the entire Laplace transformation, we were denoting it as f of t always in the entire topic. So its derivative will be surely denoted with like f dash of t, first derivative, and second derivative will be denoted with f double dash of t, and third derivative will be denoted with f triple dash of t, and so on. And nth derivative will be denoted with f power n of t. Okay, so now suppose Laplace transformation of first derivative is existing, and how it will be defining. So you see, Laplace transform of f dash of t is equals to s into Laplace transform of t minus f of 0. This can also be written as s into f bar of s minus f of 0. Okay, I repeat again, s into, where this Laplace transform of f of t is nothing but f bar of s, right? So if we replace this with f bar of s, we can write this formula, same formula as s into f bar of s minus f of 0. And similarly, Laplace transformation of f double dash of x, second derivative, is, the formula starts with s square into Laplace transform of f of t is nothing but f bar of s minus s into f of 0 minus f dash of 0. Similarly, the third derivative, that is Laplace transformation of f triple dash of t, is defined as s cube into f bar of s minus s square into f of 0, okay, minus s into f dash of 0 minus f double dash of 0. So in this way, we can define till nth derivative, means we can define the Laplace transform of nth derivatives for nth derivative of f of t. So how we are going to derive, how we are going to memorize all these formulas all together, let us try to see here. Okay. Laplace transformation of all derivatives, let us write here. So therefore you see, Laplace transformation of first derivative, that is Laplace transformation of f dash of t, is written as, since it is a first derivative, the formula starts with s into f bar of s minus f of 0. Okay, and next one is Laplace transformation of second derivative, that is f triple double dash of t, okay, is equals to, since it is second derivative, it starts with s square, and always the first term possesses f bar of s minus, you decrease the s exponent, that is s power 1 into f of 0 minus s power 0 means 1 f dash of 0. And similarly, Laplace transformation of f triple dash of t is defined as s cubed into f bar of s, okay, minus s square into f of 0 minus s into f dash of 0 minus f of 0. So similarly, what is going to happen for fourth derivative? This fourth derivative formula is going to start with s power 4 f bar of s minus s cubed into f of 0 minus s square into f dash of 0 minus s into f double dash of 0 minus f triple dash of 0. And in the same procedure, we can write the formula for nth derivative also. How we can write the formula for nth derivative? Okay, so Laplace transformation of f power n of t is equals to s power n into f bar of s, okay, minus s power n minus 1 into f of 0 minus s power n minus 2 into f dash of 0 minus s power n minus 3 into f double dash of 0 minus s power n minus 4 into f triple dash of 0, and it's keep on going, and the last term will be f n minus 1 the derivative of 0. So like this we can have Laplace transformation of different derivatives. So by memorizing this formula and by utilizing this formula, we are able to find out few Laplace operators. And how we are going to find all those, let us see. So here we can see few examples. Laplace transformation of f dash of t means Laplace transformation of first derivative formula we are going to utilize here. And here the function is f of t is equals to 3t square. Okay, so we can also find out Laplace transformation of 3t square directly. But now we are supposed to find out, otherwise we need to prove that Laplace transformation of 3t square is equals to 6 by s cube. Any two kinds of questioning. We need to prove the statement, otherwise we need to find out this Laplace transformation of 3 into t square. Okay, so how we are going to do this? So first let us try to see what is f of t. F of t is given as 3t square, isn't it? F of t is equals to 3t square, whose derivative is f dash of t is equals to 60 here. Okay, and according to formula, Laplace transformation of first derivative is s into Laplace transform of f of t minus f of 0. Okay, so Laplace transformation of 3 into t square becomes, it remains as it is, minus 3 into f of 0. F of 0 means we need to put t is equals to 0 in this f of t. In this f of t, if you put t is equals to 0 on either sides, we will have f of 0. So if you put t is equals to 0, 0 in 0 square becomes 0, 0 into 3 becomes a 0. So therefore f of 0 becomes a 0. So this last term has become 0. Here this 3 can be kept outside. So 3s into Laplace transformation of t square minus 0. That is 3s into Laplace transformation of t square. We know that Laplace transformation of t square is nothing but how much? 2 factorial divided by s cubed, which is nothing but 2 divided by s cubed. So if you substitute that and if you try to cancel 1s here, we are going to have 6 divided by s square. So like this, we can find out Laplace transformation of f dash of t. Otherwise, we can prove this Laplace transformation of 3 into t square as 6 by s square. So by using like this derivative formulas, we can calculate Laplace transformation of few kinds of functions which are derivatives. Okay, so thereafter, as we have discussed in the beginning of the video, that is, we are going to discuss about Laplace transformation of derivatives and integrals. So after understanding about this Laplace transformation of derivatives, let us move on for integrals. So what is this integral mean? Laplace transformation of directly in the given question, we are going to have a integral. Okay, so then like this, the question will be of this kind. That is, like if Laplace transformation of f of t is equals to f bar of s, then Laplace transformation of integration over 0 to t f of u du is equals to f bar of s divided by s. This is how pretty easy you see. Whatever the integrand we are going to have here behaves as f of t, and by applying Laplace transformation of that particular f of t, we are going to have f bar of s. Okay, so by integrating this divided by s. So Laplace transformation of f bar of s divided by s. Okay, so let us see one simple example here. We are supposed to find out Laplace transformation of 0 to t integration over 0 to t e power minus u into cos u du. Okay, so according to the formula, what we are supposed to write 1 by s into Laplace transformation of this integrand. That is nothing but our f of t. So Laplace transform f of t is f bar of s. So okay, let us move on. Laplace transform of e power minus u into cos u is nothing but the s plus 1 divided by s plus 1 whole square plus 1. How? How means here by using first shifting theorem. By using first shifting theorem. By using first shifting theorem, as we have discussed, like whenever we are having combination, one of the term is exponential term, shortly we will utilize this first shifting theorem to find out it's a Laplace transformation. So okay, let us do it. E power minus u into cos u. So Laplace transform of cos u is what? S divided by s square plus 1 square. But here, along with cos u, we are having e power minus u, so this s should be written as s plus 1. S plus 1 whole square. So what we have written, you see, s plus 1 divided by s plus 1 whole square plus 1 square. So after simplification, this one is the quite the output of this Laplace transformation of integral 0 to t e power minus u into cos u. So like this, we should utilize the Laplace transformation of integral formula to evaluate the Laplace transform of integrals. Okay, so hereafter, let us see few more examples here. So here, first one, if you see, Laplace transformation of integration over 0 to t e power minus 2t they have given. So Laplace transformation of integration is there. So 1 by s should be written, okay, into Laplace transformation of this integrand e power minus 2t. Fine. So which implies Laplace transformation of e power minus 2t is 1 by s plus 2. So therefore 1 by s into 1 by s plus 2 becomes a result. This is the result. The next one you see, Laplace transformation of integration. Laplace transformation of integration whose integrand is cos 2t. So 1 by s into Laplace transformation of cos 2t, s by s square plus 4. So if you cancel s and s, the result is 1 by s square plus 4. Again, if you see the another example, Laplace transformation of integration, where again integrand possesses a combination. Whereas in example 1 and example 2, we doesn't have any combinations in the integrands here. Okay, but here we possess a combination. So let it be 1 by s into Laplace transformation of this complete integrand t into sine 3t. So here multiplication by powers of t formula should be utilized. Since we have t power 1 here, what we have to do? Minus 1 whole power 1, nothing but minus 1 time differentiation of Laplace transformation of sine 3t. Okay, Laplace transformation of sine 3t becomes 3 by s square plus 9. We need to differentiate this. So here it becomes, you see, actually no need to go with u by v. What we can do is 3 can be kept outside, so that minus 3 divided by s into differentiation of 1 by d by ds of 1 by s square plus 9 can be done. So minus 3 by s into minus 1 by s square plus 9 whole square into inner differentiation of s square plus 9 is 2s. s cancel. So minus 6 minus into minus plus 6 by s square plus 9 whole power 2. So like this in Laplace transformation of integral also evaluated. Okay. So therefore, if we recap both the concept what we have discussed here in this video, we discussed Laplace transformation of multiplication by Laplace transformation of derivatives and Laplace transformation of integrals. So Laplace transformation of derivatives formula is like when we have nth derivative formula is defined as s power n into f bar of s minus the power of s will be keep on decreasing, and this derivatives will be increasing from f dash of 0 means from the next term n minus 2 f dash of 0 minus s power n minus 3 f double dash of 0 minus so on. The last term will be f power n minus 1, the derivative at 0. Okay, and Laplace transformation of integration over 0 to t f of u du is defined as 1 by s into f bar of s, where this f bar of s is nothing but what? Laplace transform of f of t. So by using this formulae, we can evaluate few different kinds of questions again. So with this video, we completed Laplace transformation of derivatives and integrals. Okay.